generating function for the legendary polynomial. So these are the formulas. Standard formulas are there related to binomial theorem. 1 minus b the power minus n, s plus a the power n, and that is expansion. Those are available in BSc. I think you have done. So nc0 like n minus 1 c1 we can find from this relationship. ncr is equal to n factorial. You can put the value of n, and or you can put the value of r also, whatever is required. So you will get the relationship. So that is statement. Show that p and x is the coefficient of h to the power n in the expansion of this term, right? So we have to prove this one formula. 1 minus 2xh minus h square minus half will be equal to n is equal to 0 to infinity. So value of n we can change here. You can get n also, n minus 1, it is up to you, and we have to add all these terms, right, to get this relationship. So we can write here this term. So 1 minus 2xh plus h square. So minus h we are taking common. This is left only. So binomial series is 1 minus b the power minus n. So n is here half, and b is equal to h 2x minus h. We have put up the values here. So 1 by 1 we will put. Initially we will put n is equal to half. Then we will reduce the relationship, and then we put the value of b. Same thing done here. So n equal to half and b is equal to this one. So n equal to half I have put first, so that this type of relation you will get half 3 by 2, right? And here it is 5 by 2. Same thing I have written half, then 1 by 2, 3 by 2, 1 by 2 factorial here, and 1 3 5, right? 2 here, now 3 factorial here, and b square b q, like that. So now these terms we will get, right, from this power relationship. This type of relationship we will get, right? So okay, further we will see the later on that this formula can be from expansion. So in the above questions we have written the first. This was the first term. This was second term, third term, nth term, or n plus 1 term, n minus 1 we can also write, right? So in this way, first of all we will start from the backward. Why? Because h the power n in the first term or second term or third term and the fourth term we will not get h the power n, right? But here you can get, start from the back, h the power n here, right? Expansion of this one, this part, 2x minus h. Similarly, h the power n minus 1, you will get expansion of this part, multiplied by h. We will see where is h the power 0 here, where is h the power 1, so that the ultimate aim is h the power n. Further, so n plus 1 term was, this was the n plus 1 term. So this relationship is there, 2x minus h the power n is there. So accordingly, this is similar to x the power minus x minus a the power n. So this type of binomial we will get. So put this x minus x as 2x and a as h. So the expansion you will get. Same thing we'll put here, 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 a as h here, and x as 2x. So you will get this type of relationship. So now, ultimate aim is we have to see where is h the power n. You can see h the power n. It is h the power n here. So here from this expansion we should get h the power 0. In the first relation, first term only, h the power 0 is there. Here it is h. It is h square. But our aim is h the power n. By multiplication we should get the h the power n. And if here we will get h the power n. So accordingly, it means this term I will write only to the power n, like that. So common 2 common from here, 2 from here, 2 from here, 2 from here, write to the power n. And left is 1, 2, 3, n, right? 1, 2, 3, n is basically n factorial. So 1, 3, 5, 2n minus 1, n factorial, x to the power n. This 2 to the power n cancelled. So left is 1. So in all the relationship we will see This part is common. 1, 3, 5, 2n minus 1 n factorial, and as the power n, this term will change also, right? Other things will be, this part will be same. You will see later on. Now, next is n term. N term we will get from this here. It means h the power n minus 1 is already there, and we will get h from here. Like expanding this part now, right? This part. In this type of expansion we can get from this binomial theorem that we already written. This type. So we will put x to x, a as h, and put other values. And n minus 1 we are getting here. N minus 1 c0, that is equal to 1, right? Like that one. So n minus 1 c0, right? We are getting here x as 2x. So 2n minus 1, so x n minus 1, and already we have h the power n minus 1, right? So it means we will find where is h. In this case h was not there. Here is h. Here the h square. It means our requirement is this part, because h the power n minus 1 is already there, and we want h the power n. Now combining this equation b, and this part, green part. So we will get h the power n coefficient. So 1, 3, 5, 2n minus 3, like that, 2, 4, 6, 2n minus 2, right? And then this part from this part, minus 1, right? 1, and c minus n minus 1 c1, like that, right? We already calculated the value of n minus 1 c1 here. That value is n minus 1. It means this part you can write as n minus 1. So minus n minus 1 will be there. So now you can see here to n minus 3, it is 2n minus 2 here, right? So our aim is, in the above term, it should be 2n minus 1, and the denominator should be n factorial. That we will try to do. Now here you can see 2 comes from here, 2 from here, 2 from here, 2 from here also. Here the left is n minus 1. It is 2 from here, 1, 2, 3, n minus 1 times, mean 2 to the power n minus 1. Right? N minus 1 is here, 2 n minus 3 is there. Already we have discussed, our aim is, in the above term, it should be 2n minus 1. And in the denominator should be n factorial. Here n factorial is not there. So we will multiply and divide by the 2n, both sides. So we will get the term, right? So further, so what you will get is, and simply above here also, our aim is 2n minus 1. So divide and multiply by 2n minus 1 to get that value, like that. 2 to the power n here cancelled with the 2 to the power n minus 2 is here. It means to get 2 to the power n, we have to divide and multiply it by 2 square, right? About 2 square can be observed here, and left is only here. So 2 to the power n, 2 to the power n cancelled. So left is 1, 2, 3, 5, 2n minus 3, 2n minus 1, n factorial, and this is n by n minus 1, n minus 1 divided by 2 n minus 1, right? X to the power n minus 1, like that. Because this 2 and this 2 square, right? 1, 2 will be cancelled. So that we have only 1, 2 is left. Other terms are same. So what we are getting. Similarly, from the n minus 1 term, this type of relationship we will get. So you will try to see by expansion of this term. At n minus 2 already there, and our requirement is h to the power n. It means the term where h square is there, that we will want to see. So expanding this one, expansion can be done from this relationship. You can put x as 2x, a as h, and n minus 2 already there. So you can expand and put other values. You can see here h to the power 0, not required. H to the power 1, not required. H square, that is required. Why? Because h n minus 2 was already there. So we can combine them. So first, second, and third term multiplied by this factor will be the h the power n coefficient, right? So 135, 2n minus 5, so 246, 2n minus 4, like that, right? N minus 2, C2, H, right? So H square, uh, 2n minus 4, x n minus 4, already x n minus 2 already there. This H2 will be resolved there. So coefficient of H will be, Hn will be this part only. Because Hn is not recovered here because coefficient we are seeing. So now you can see n minus 2, C2, this will be the answer. Even we can write, in place of this relationship, we can write n minus 2, n minus 3 to factorial. And same thing as in the previous relationship also, 1, 3, like n term or n plus 1 terms, we were getting a similar type of relationship here. And similarly, here we are getting n factorial. So same thing we will try to do. Like here, 135, right, 2 and minus 5, 2 n minus right 3. This formula is from this standard formula, n minus 2 C2, right, 2n minus 4, our a with 2n minus 1, so multiply by 2n minus 3, 2n minus 1, right? And here also you can get 2 from here, 2 from here, 2 from here, and here 2 and n minus 2. It means 2 the power n minus 2 is there. So 1, 2, 3, 4, n minus 2. Left is, but we want n factorial. It means we will multiply by the further relationship. We will multiply n minus 1 by 2, n minus 1, n also, right? So that to the power, this can be combined together to get n factorial, right? So same thing we are getting. So because now this n factorial is there, like this one, this part is n factorial, 2n minus 3 minus 1, 2n minus 1, 2n 1 minus 3 already there. So power relationship like that. So you can skip these terms also, no problem, right? Like 5, I will draw up to 5 only. You may write 7 also, 9 also. So to simplify, 135, 2n minus 1, n minus 1, right? N minus 2, n minus 3, already same thing, right? So x to the power n minus 4, 2n minus 4, right? Like here. So to the power n minus 4, to the power, we have tried to resolve the factor similarly, so that because we were getting to the power n minus 2 here. Why? Because it is 2n minus 4, meaning 2 common means 2n, sorry, n minus 2. So to the power n minus 2 here, but here it is to the power n minus 4. So to get that, we have multiplied by 2 the power 2 and divide by 2 the power 2 also. So 1 to the power 2 will be resolved here. So that will be 2n, so to the power n minus 4. So now to the power n minus 4 here also cancelled, right? And the one, this 2 square will be here, right? So 2 factorial here. So rest terms are same. Now coefficient of h to the power n, in the n 1 minus term is this one, 135, 2n minus 1. So n factorial. So 2n minus 4, 2n minus 4 cancelled. Left is n factorial, 2n minus 3, 2n minus 1, right? 2 factorial here, right? And 2 square here, right? Here to this 2 square is from here. So same thing here, right? And n minus 2 c2, that we already written the previous slide also, same thing, right? So what we are getting now, this is the coefficient of h to the power n in n minus 1 term. So we have calculated the coefficient of h to the power n in n plus 1 term, n term, n minus 1. Similarly, you can calculate for n minus 2 also, n minus 3 also. Only thing is we have to see from which term we can get h to the power n. So from the n1 term, we will get this type of relationship, and from h to the power n, we will get this term type of relationship. Plus here, minus here, plus here, further minus will be there. This part you can see common. 135, 2n minus 1. Same thing here. 2 minus 1, 3, you can write or skip, it's up to you only. Like here, 5 I have written only. You can go, may write 7 also, write 9 also, here also you can write same thing. Means last term I have written so that to cover the space, nothing else. Okay. 3, this 1, 3, 5, 2, n minus 1, right? And factorial common, same thing here, right? So this term is extra. So what was calculated in n minus 1 term? So x to the power n, x to the power n minus 2. So adding all the h to the power n coefficients from the different terms. N term, maybe n1 plus terms, n plus n minus 1th term, n minus 2nd term, n minus 3rd term, like that. So adding all the term, one this was common, 1, 3, 5, 2 n minus 1 n factorial, and left is only this part only, and so on. Minus, plus, right? Then furtherly minus and so on. So this part common, 1, 3, 5, that I written common part, right? As the power n, and this part left, right? And similarly n minus 1, n minus 2, n minus 3. So 2 factorial, 2 to the power 2 is 4, to make a symmetry, nothing else, because it was 1 factorial, 2 factorial, like that, and 2 and 4, like that, to make it symmetry, and so on. So this part is basically the legendary polynomial, that is Pnx. What is that? That is coefficient of h to the power n. Similarly, from h to the power n minus 1 or any term, any power you get and add all, that this term will be there. This is n is equal to 0, infinity h to the power n, Pnx. That was the relation asked further. So statement we have written ascending power x. So to explain that, you calculate P0x, Pnx. From Pnx, you can put n equal to 0, P1x, P23, P2x, P3x, and so on. You can see as the power 0 it is there, x, 3x square, x cube, so on. So as the value of P0, P1, P2, P3, P4 increase, as the power will increase. That is ascending power of x. So in this way, the expansion we can do, and the coefficient of h to the power n we can calculate to show the generative function. Thank you.